All right, AGS1, we're back with 4.2, Elvira's equations. So fitting for spooky season, which I guess is technically over, but whatevs. The essential question today, what does it mean to solve an equation that contains multiple variables? So you're going to see that word solve. That's going to come up a lot in this lesson where they give you an equation and they ask you to solve for a certain part of it. The thing about today's equations is they're going to have lots of variables in them. So there's no way to like solve it down to a certain number. We can't get like x equals 2 or something like that. So when they say solve, they mean just like, I like to think of this as get by itself. So first up, we have a plus b plus c plus, or no, a plus b plus c equals d. And we are going to solve for a, which means we need to get this all by itself. Now, down the road, I'll tell you guys just to kind of play the opposite game, where you sort of undo PEMDAS and get a by itself by doing all these opposite things. But after seeing some other AGS videos and things, I want to also talk about the do-undo table. So, in terms of the do, if you look at A, you can see what has been done to A to get D over here. So first thing that happens to A is it gets a plus B. So put a plus B in your do table. Then it gets added by C, so you put a plus C in your do table. And then finally, the whole thing is equal to D. So you put an equal to D in your do table. Now, ignore my backups. We are going to undo all this. So first, you start with D down here at the bottom, but then to get back up to the next step, so to go from here up to here, you need to do the opposite of a plus C, which is subtract C. Then to get up to the next step up here, you do the opposite of a plus B, so you subtract B. Then the very last step is that should be equal to A. So let's keep track of all this over on the right here by doing those actual steps. The first thing we did is subtract C right here. So if we subtract C from both sides, like you could think of it like, you know, you're subtracting C underneath and subtracting C over here, but essentially these get canceled out and you get A plus B is equal to D minus C. Please notice that the D minus C is the same as the D minus C here in our undo table. Then the next step is to subtract B. That's right here, the minus B part. So if you subtract B from both sides, you get D minus C minus B. Now, you could put that in a couple different orders, like it could be D minus B minus C, but as long as you get A by itself, then this is like your correct answer. So you can stop here. I'll put a box around it just because A has been solved for. It's been got by itself. Next up, xy minus z equals w. Remember that the x and the y are being multiplied together, but we don't always write the little dot in between them. So if you see two letters next to each other, they're being multiplied. So we're going to solve this for x. Let's do our do-undo table, starting up from the bottom. So you always want to go from the bottom up with the do-undo table. First, we're going to start with w, then do the opposite of subtract z, which is add z, then do the opposite of multiply by y, which is divide by y. And then this should be equal to x. The way I set up this table right here is just by looking at what's happening to x in terms of undoing. It's like first it gets multiplied by y, then it gets subtracted by z, and then it is equal to w. So it's like first thing multiplication, second thing subtract by z, third thing equal to w. Gosh, that is gnarly. Let's get rid of all that. Then we need to do all that in that order. So we're going to look at our undo table and just go backwards like this to the equation. So the first thing we do is we add z to both sides. So xy is going to be equal to w plus z. I like to think of it as just like you're actually taking the minus z and like moving it over to the other side. But anytime you hop the equal sign, you just have to do opposite. So opposite of subtract z on the other side would be a plus z. So it's like you take this and move it over here, and it would become a plus z. Then the next thing is we need to divide by y. So just looking here, x is not by itself because it's being multiplied with y. So we just have to divide both sides by y. So if we divide here, divide this by y and divide this by y, these y's cancel out and you get x is equal to w plus z over y. And then it is done because you got the x by itself. Remember, if it says solve for x, you just get x by itself and you're good. Next one, 2x plus 2y is equal to 4, and we are going to solve for y. So we're not getting the x by itself, we're getting the y by itself. The first thing that happens to y is it gets multiplied by 2, then it gets added by 2x, and that whole thing is equal to 4. So if we build our undo table, remember going from the bottom up, it's going to be 4 subtract 2x divided by 2 is going to be equal to y. And that actually kind of is the answer. The answer is 4 minus 2x over 2 is equal to y. But once again, I like to kind of think of the algebra as just like you're trying to unlock this thing, so you start getting rid of things on this side to undo it. So to undo a plus 2x, like this 2x has a positive, and move it to the other side, that means on the other side it's going to be a negative 2x. So you get 2y is equal to 4 minus 2x. Because when you move a positive 2x to the other side, it becomes a negative 2x. Then the only thing stopping us from getting y by itself is the times 2. So you got to divide both sides by 2. So we can divide by 2 here and divide by 2 here. These cancel out and you get y is equal to 4 minus 2x over 2. Oh, but you know what, you guys? There's a simplification we can do here. Yes, we got y by itself, but do you see how this 2 can go into this 4 and this 2? That means if everything in the numerator is divisible by the denominator, you can sort of reduce it like a big fraction. So this becomes 2 minus x, and then the 2 on the bottom disappears. So the 2 went into the 4 and into the 2. So 4 over 2 is 2, 2 over 2 is 1, but we don't write the 1. Now, you guys, this one's going to be similar to some of your problems in your formative today. So, given this big old equation, we're going to solve for b. So, we got to get b by itself. The first thing that happens to b is you get a plus c, then a plus d, then it divides by e, and then the whole thing is equal to a. So, if we build up the undo table, start with a, opposite of divide by e is multiply by e. Subtract d, subtract c, and this should be equal to b. So once again, this is your answer going this way. It's like a times e minus d minus c is equal to b. So, you guys, up here in this equation, if you want to get rid of a divide by e, you just need to multiply both sides by e. And then this e and this e will cancel out, leaving you with AE, or EA, it doesn't matter which order, equals B plus C plus D. Then, according to our undo table, we need to subtract D and subtract C. So the way I think of that is that like this positive B needs to come to the other side and be negative. So it's like AE minus B, and then is equal to C plus D. Oh, hold up. I'm moving the wrong variable. Sorry, guys. We're trying to get B by itself. So we need to move D. I should have looked at my undo table. I need to move the D over to the other side, which will become a negative D. So it's AE minus D is equal to B plus C. Then I need to subtract c from both sides, so move that over, and it becomes opposite as well. So AE minus D minus C is equal to B. And then voila, B is by itself. Now, some people might be uncomfortable that the B is on the right-hand side, but it really doesn't matter. It's still on its own side of an equal sign. If it makes you more comfortable, you can rewrite it as this. This is the exact same thing. You can always flip it around. That's not breaking any math rules. All right, one last example for you guys. M equals n plus times the quantity of P plus Q. We are going to solve for n. So this one's kind of funny because it seems like there should be more to it. But if you look at why n is not by itself, it's really only because it's being multiplied with P plus Q. So if we do our undo table, you start with m, and then the opposite of times P plus Q is to divide by P plus Q. And then this should be equal to n. So the way I think of it, let's rewrite our equation over here just so I have a little more room, is that, that should be a little closer, that the n is not by itself because of that multiply by P plus Q. So if you want to get rid of a multiply by P plus Q, you can just divide by P plus Q. But you can't just do it to one side, you have to do it to both sides. So these cancel out, and then m over P plus Q is equal to n. And you don't technically need these parentheses. They're not really doing anything. So I guess we could just say, and we'll flip it around too for all you left-handers out there, m over P plus Q. I'll box my answer to stay consistent. Okay, you guys, I think that's all I have for you for today. I'll help you with the go formative as usual.